Then we need to check for which situation we have. So we could have 0 triangles, which means that A is less than B and H. We could have 1 triangle if A is greater than B, side B, and our H. Yeah.
You said SSA and SAS means they could go into the two sides of one angle.
Yeah.
Aren't they the same because SAS is two sides?
So 2 sides and the angle outside. So this is like this. I give you, you could start with the angle. I give you the angle and I give you, so this is A. No, I'm sorry. I give you whatever this is. Let's say it's 20. This is A. I'm going to try to find what's over here. This is what B is. Okay? I give you 2 sides. It's angle. This is the side right next to it. So it's 5, let's say. And over here, let's say it's 10. So where did you get 30 from? This is 20. This is 5. This is 10.
This is SSA.
So quiet in here. All we could hear is you outside. This is angle, side, side. It's the same thing as side, side, angle. Yeah, I just don't want to write that word on the board. Because you don't want to write ass on the board. Yeah. 2 triangles happens when the height is less than side A, which is less than side B. If I'm up here, I'm labeling A, which is opposite of my angle. This is A. Over here is B. My height, I draw for my vertex going down. Makes 9 degrees height. And we're always doing sine of my angle equals my height over my side B, in this case, which was 5. It's always going to be sine. These are nice steps to have. So remember. So once we figure out the height and figure out what it is, then we need to solve for angle B using law of sine. If we have 0 triangles, then we stop. For this one, we solve. And this one, we solve. We can stop if it's 0.
Here today.
I also did. He left. So did Desi, and I saw Desi today.
Yeah, we had I was like, yeah, maybe he just left.
What's up? Then, okay, let's say you had a triangle like this.
Does that say station?
Station? Situation. Situation. Okay, if it's like this, then my height is right there. This is my height. It kind of extends out. That is height. This would be like, I don't know, like 190, say? No, not 190. That would be funny. What? To figure out what situation we have. Do we have 2 triangles? Do we have 1 triangle? Or do we have 0 triangles? If we have 0 triangles, if we have 1 triangle, if we have 2 triangles. Because we could have multiple solutions for this type of case. If we have this, we could have multiple examples of multiple solutions to what B is. Because remember how we did the compass thing? Yeah, and it made 2 separate triangles. And they both had the same exact like requirements. It was side 8, side 6, and 30 degrees. But there's 2 possible solutions to that triangle. There's the small solution triangle or there's the big solution triangle. So we need to know how many triangles it would make. Jade, what does the inequalities mean? What does the inequalities over here mean? This is telling me how many possible solutions I could have for A. I could have one solution, could have 0, I could have 2. No, this is just like the middle step. We have to check for height to figure out how many solutions we have. These are just label. This is just these are our steps. These are my steps. This is labeling steps. This is solving steps. This is checking for how many, what's the height. Then we have to solve it and actually find the angle. This is in sequence. This is label. This is label. This is find the height. Find the height. Figure out how many solutions we need to solve for. Down here in blue is the actual solving to exactly define what B is. So solve. Oh. Solve for angle B using law of sine. That's the end. If we have two triangles, take angle B and subtract it from 180 degrees. That is my last step. It's a lot of steps. This is steps in detail, Kian. Step 1, 2, 3.
Where?
1, 2,
Oh, okay.
3, yeah,
I thought there
4,
was no
5, 6.
And so,
First 2 is the labeling. Second 2 are trying to find the height and trying to find out what solution, how many you have to solve for. Mm-hmm. We're moving away from this now. We're not talking about triangles again.
Really?
Yeah, we're talking about something else now. No.
Circles.
Jade, I saw it. We all worked.
Matrices?
Yeah. Matrices.
My brothers were all saying that's what made them have the most struggle.
It's easy. It's easy.
Yeah, right.
It's easy.
Coming from matrix, we're dodging. They're really smart.
Okay.
Actually, the sixth one.
Okay. A matrices. If I give you
He's smart. He doesn't try.
If I told you to solve this for x and y, could you do it?
No, 1 and 2.
2 times x.
Right break.
No.
We didn't
Have
even
it.
vote. You said we would have a break break. Oh yeah. We never even had a break break.
If I were to solve this, what would I do? These are 2 different ones.
Add them together. Swap x and y. Equal them to 0. Move 1.
I would isolate a term and then plug in. Substitution, right?
Yeah.
Okay, when they get really uglier, like 3y, right, w, plus 2y plus, I don't know, 4x plus 5y equals 4. And then 3y plus 10z minus 2y equals 5. And 4x plus 12y plus, I don't know, 20w equals -1. That's ugly. That's a lot of work. Can't really isolate a term. We can, but it's a lot, right? And it would take a long time. That's when matrices come into play. This is good for operations and plugging it into other things. Okay? We're not going to do that. We're not going to get that advanced. But we got to see what we would get to. Kind of thing. Some people were out that day. Okay, Jade. Put that down, please. We are getting into matrices. So 10.1. This is operations. No. That was 8. That was 8.
Skip 9?
Yeah, we skipped 9.
Oh yeah.
Hallway
I
in.
just hate the clinching.
You don't like this?
I hate, yeah. I'll
That's
hate that.
you don't like.
I hate that sound. I really do. Okay, operations with matrices. Matrices, that is what we have. Okay, a matrix is a great way to represent data in a linear on that type. Like we can take all that and take all the coefficients and put them in the matrices and solve them. So how we organize data, yeah, as a gigantic bracket. So A equals, give me some numbers. Okay, keep going. 42, 8,
11,
11, 16,
30.
30. I'm going to stop there.
6.
Wait. Okay, how many rows do I have in this matrix right now?
2.
Yep,
2.
2. I have 2 rows. How many columns?
3.
3. So this is how I do a dimensions of a matrix. So this is rows. 3 is my columns. Oops. Columns. So this is row 1, row 2. This is column 1, column 2, and column 3. This is an A matrix. So this is known as matrix A. We might see it as M, the subscript of A. These are both matrix, but A is going to be in uppercase. Okay. We have 2 by 3. 2 by 3. We call this my dimensions in a matrix. How many numbers do we have in this entire matrix? 6. We call this 6 elements in a matrix. What? Is a what? An element? Yeah. Yeah. It is an element in all of them. So this also might be called an n by m matrix. If these are 2 different numbers, it's an n by m. If it's the same number, like 3 by 3, it would be an n by n. Right now it's an m by n. N by m. Jade, give me 2 numbers. No, small numbers. 1 and 2. So make me a 1 by 2 matrix. Make me a 1 by 2 matrix. Any number, I don't care.
So what do you write the matrix?
So that's all?
Yeah.
That's literally, we just find out how many elements are?
Well, I want you to make me a matrix that's 1 by 2. This is just what is a matrix, dude.
6, 7.
Yes.
Write it.
What do you?
1.
Make me a 1 by 2 matrix and then make me a 2 by 1 matrix. I want you to do 2. Make this B. Matrix B.
5 elements?
You can write anything you want. I don't care what numbers you put down. Yeah. We have like in a theater, like a row. It's like
So I don't.
Okay.
6, 7, it's 6, 7.
I did this opposite.
you go row. How many rows do we want? First thing is always rows. If I give you what's my question?
Got it.
2.
Alright. You good?
1.
1. So I have 1 row. I'm gonna have 1 row. That is it. So
It's not complicated. It just like switches in my brain.
No,
Like
no, no.
Rows and columns.
I get it too. So
Columns.
I gotta think of like an Excel chart, and I think of columns that way. So, oh, you know how I do it? Columns have an L, right? L goes up and down. That's how I do it. Row is an R and it's small, but an
Wait,
L, yeah.
Column goes up and down.
Column goes up and down because an L is really tall.
You know what a good way to think of this is?
That's how I do it. Yeah.
How many rows of desks there are? You're not asking how many columns.
No.
Is this a column?
No.
No, yeah. Up and down is a column.
This is a.
That's it. What if you're looking down?
So I would have 1 row and 2 columns. So let's call this 2 and 4. I have row 1, I have column 1, and column 2. How is this different?
We went to
Two-
all the same
wait.
parks.
Really?
To all of those. We did a giant road trip. That's actually
Mhm.
weird.
I've been to about 21 state
Really?
national parks.
I have a book with stamps.
Mhm. I have a map. A map that's a wooden map.
What?
Yeah. No, well, it's back.
We went from Vegas to Vegas. And we just did a giant.
I've never been to Vegas.
I go to Vegas, but I get stuck in a hotel while they go gamble.
That's what happened with me.
Never gone.
Wait,
Oh, yeah.
2 by 1. Come on, 2 by 1.
6 and 7.
2. Okay, 2 and 4. Put one on top, one bottom. So that's the difference. This is just matrix B. These are two different matrices. 2 by 1. Okay, let's do a C matrix. It doesn't matter what the number you call it. We're gonna make a. What did we do above? We did a 2 by 3. So make a 3 by 2. 3 by 2. Jacqueline, give me a number.
6.
6. Give me another number.
7.
You know what? Never mind. Okay. How many rows do I have? 3. So I have row 1, row 2, and row 3. How many columns do I have? 2. So I have 1, and I have 2.
No matter what number we put in, right?
No, but this one it's gonna matter. We're gonna call these elements. They're not gonna be. We're gonna use subscripts. So when we're talking about row 1 and column 1, this is A. The row is 1. Column is 1. Am I talking about the next element? I would say
2.
A. Yep. 1.
Oh,
2.
I see.
So Lucy, what would this one be?
That would be A2.
What column am I in? 1 or 2? 1.
You're
Yep.
messing me up.
So then what would this one be? A. 2. 2. 2. Yep. Jade, what would this one be? A sub. Three and 1. Yep. Kian, what would this one be? A sub. Start with my row first. What row am I in?
Oh.
What column am I in? 2. Yep.
Did you notice? In column 2, it just goes 1, 2, 3.
Yes. It's gonna keep having that pattern.
It's like the unit circle.
Okay. I'm gonna give you numbers 5, 6, 4, 2, 11, 10. Okay. What is A sub 2, 2?
2.
What's A sub 12?
6.
Yep, I want everyone to say it. A sub 32.
10.
How would you know that?
So A sub 32
Oh.
is that element right there. Yep. What's A sub 31?
11.
What is A sub 11?
5.
What's A sub 21?
4.
What's A sub 12? A sub 22. Lucy, A sub 31.
Thanks, Lucy.
11.
Yep. A sub 11. Lucy. 5. Yep. Okay, that's basically what a matrix is. We'll talk more about. Yeah.
Wait, no, it's hard.
I know.
We're not even get to the hard stuff because
Well, isn't Simon? I have a feeling that my brother just said it was hard because it's the only thing they remember.
it's we're only gonna multiply matrices and not even all we're gonna do is scale one, and we're gonna add and subtract them. That's it.
Okay.
Yeah.